Let's determine the pH of a buffer given the acid and its conjugate base. Remember, the acid is going to donate the hydrogen, the base is going to accept the hydrogen. So here's our acid, formic acid, there's its conjugate base, and this is formate, a formate ion. So given, I have 0.5 of my acid, 0.7 molar of my conjugate base. When you are given an acid and its conjugate base, immediately I want you to think of the equation Henderson-Hasselbalch. This is always where you live to find pH when you have the acid and the conjugate base. Here's our formula for Henderson-Hasselbalch. pH equals pKa plus log of conjugate base divided by acid. Just a reminder, you can put moles or molarity in for your units. And then our pKa equals the negative log of Ka. Here, I found the Ka to be 1.8 times 10 to the negative 4. Plug that in. Negative log of Ka, 3.74. At this point, easy. Plug and chug. pH equals 3.74 plus the log of conjugate base, 0.7, divided by acid, 0.5. And we got 3.89. I like to point out, notice that the final pH is greater than the pKa. That would make sense because we have more base, conjugate base, than the acid. So I would anticipate that this pH would be higher than the pKa. Just a reminder, pH equals pKa when the conjugate base and acid are equal. That would be log of 1 if they're equal to each other. Log of 1 is 0. pH equals pKa when you have equal amounts. So if I have more base, I would anticipate that the pH will be higher. All right, great work. If you need more help, please check out my playlist, Acid Bases. You can get more help on buffers. Please like and subscribe. Thank you for watching Old School Chemistry. Take care. Bye.